All right, so yesterday what we did is we talked about how we solve trig equations using identities, right? So today what we're going to do is we're going to learn how to solve those same trig equations, but graphically instead of algebraically, okay? It's actually pretty simple, but you do have to know the ins and outs of your calculators to make sure that all your windows are set correctly and that the graph is viewable in the window it's in. All right, so go to the next page. We're going to graphically solve the equation 2 cosine x plus 1 equals 0. That should say for all values of x on the interval from 0 to 360 degrees. Sketch and label a graph to justify your answer. Okay, so graphically, how can I solve this? Type what in? The 2 cosine x plus 1. Yeah, why don't I put in equals 0? Yeah, that's your y, okay? So you have to type in the 2 cosine x plus 1. Now, what are we looking for graphically to happen? Where are my solutions found? Be a little more specific. Where do I find solutions? When I graph this, where am I going to look for my solutions? The x-axis, yeah. When the function equals 0, that means when it intersects the x-axis. Okay? All right, so I'm going to come over here. Control G brings back up your function bar. And we're going to put in 2 cosine of x plus 1. What's wrong with this picture? Definitely the wrong interval. Good. How do I change that? Yeah. Okay, so we need to change my window. My window is completely wrong. I want it on the interval from 0 to 360 degrees. I don't have that right now. I have from 0 to 10. Okay, so I'm going to double click on my y maximum, and I'm going to adjust that. Looks like I don't really need any more than 4. Okay, so you're looking at your graph, you're playing with the values to see what's going to fit. Hit tab to get over to your x maximum. What do I want my x maximum to be? 360. Good, that's the interval I'm dealing with, right? My x min, x max are given to me. That's the interval in which we're solving for. Hit tab to go down to your y minimum. It went ugly, huh? We'll fix it in a minute. So what do you think I need my y minimum to be? Yeah, we could try -4. And how about my x minimum? 0. Good. And then hit enter. Super ugly, right? Anybody have any ideas as to why it's so ugly? We've got an issue with my settings, okay? We want from 0 to 360 degrees. What do you think this is in? Radians. Okay, so we need to change our setting for our graph page so that it's in terms of degrees instead of terms of radians. What I have right now is 0 to 360 radians. That's huge. It's too much, okay? So what you're going to do is you're going to hit your menu. You're going to go down to Settings. And this is really important. Notice this says float 3. Do you guys know what float means? Float means how many numbers the calculator will give you on the screen. So if I'm looking for solutions and I get a solution like 124.67, it's only going to show me 124, 125 when it's rounded, okay? We want more than that. So you want this float to be at least 6. 6 is generally a good place to be. Okay, so float 6 is going to give you enough places so that you make sure if it says round to the nearest tenth, you're actually getting that tenth. Okay? And I want my graphing angle to be in degrees. Okay, that was my interval, 0 to 360 degrees. It didn't say 0 to 2 pi. And then we're going to click OK. Now, that's much prettier, right? We like that much better. Okay, so again, where do I find my solutions? Where it intersects the x-axis. Good. How do I get those? Good. We can use point on. How do I use point on? Menu. No. Geometry. Points and lines. They changed it from last year. Points and lines. Okay. Now what? Play nice. You do. I am frozen. Ha. Never mind. Yeah, I'm good. It's Tuesday. Point on. Okay, now what? Click on the graph. Yep. Hit enter and escape. So click, enter, escape. Okay. Is your tool still in the upper left-hand corner? You don't want it there. So click on it, hit enter to set the point, and then hit escape. Okay, that means your point on tool, you have your point on the line, but your tool isn't left open to wreak havoc when it shouldn't. Okay? All right, so now what you can do is you can just pull that point, right? Notice it said 0. It said the word 0. 0 is another word for roots or solutions. Zeros, roots, solutions. Please know that they mean the same thing, okay? Well, zeros and roots, there's a difference, but for our purposes right now. Okay, so we get 120 as one solution. You're going to grab that point and move it again, and you get 240. So your solutions should be written like this. Okay, so if you were to do this on the Regents exam, the way that you would have to show your work is you would have to graph it just like this. It would have to be labeled. Your axes would have to be labeled. Your units, your 4, your x, your y, all of this stuff would have to be labeled. Your points would have to be labeled. All of this would have to be done. Is it enough? No, because you also need this. Don't ever box your answers on the Regents exam.
Wait, why?
You did something wrong. Why what? You should never ever box your answers on a Regents exam, because if you have the correct answer somewhere else, I can't give you partial credit for it if you've boxed the wrong answer. Okay? Never box or circle anything, guys. That's a big no-no. Okay, so this is what you have to have on the Regents exam in order to get full credit for a graphical solution. Okay? The graph, and not an ugly sketch, the nice graph with everything labeled in there. And then your solutions written on the outside. Okay? Got it? Okay, good. It's not that bad, right? Okay, next page. All right, so graphically solve the equation 15 cosine squared x minus 7 cosine x minus 2 for all values on the interval from 0 to 360 degrees. Same thing. You're going to graph it. You're going to adjust the window. You're going to adjust the graphing settings if you need to. Now, when you go to graph this, and I need you to pay attention, okay? Remember, this gets put in a very specific way. The square doesn't go where you see it now when we put it into the calculator. This is what it's going to look like. Exactly the way that I'm writing it. Notice how many parentheses I have. Okay, it has to look exactly like that. So that is what you're going to put in. If you mess that up, you're going to get the wrong graph. Okay, so go ahead and graph it, and then we'll talk about it. Find the solutions. That's what it should have started off looking like before you changed your window. And remember, you can just keep going around until you have a window that looks good to you. Okay? Just keep hitting tab. What's it say? Okay, so now that I have a nice pretty picture, I want to find those zeros, right? Those solutions. Menu, geometry, points and lines, point on. Click, enter, escape. I grab that first one and I get to nearest tenth, 48.2, and then 1.5, and then 258.5, yep. And then 311.8. Okay, so what were they again? Somebody read them off to me. 48.2. Okay. And those are your solutions. Okay, so the biggest struggle here is just making sure you type it in correctly. And that shouldn't be much of a struggle. Okay? You have to make sure you type these things in correctly, otherwise you're not going to get it. Can we move on to the next one? Okay. All right, so make sure that you think carefully about what window you're using. We talked about this. We know that if it says 0 to 360, we're going to use degrees. If it says 0 to 2 pi, you're going to use what? Radians. Okay, so you just have to make sure you're careful of that. All right, so I want you to go ahead and try this next one. Find the solutions, and we'll talk about it in a minute. All right, so we have 3 cosine x squared minus 7 cosine x minus 6. Okay, change my window. I know I'm going to start at 0. Maybe, what did you use? 5, okay. And 360, and would you use for your, okay, good. So that's pretty nice, right? So my last step is to do what? Yeah, menu, geometry, points and lines, point on, click enter, escape. My first 0 is 131.8, and my second 0 is 228.2. We good? What's an integer? An integer is a real number. Give me more. What? It is definitely a number. Whole number can include what? No, that's irrational. Nope, that's rational. What? Nope, that's irrational. It cannot include decimals. What can it include? No. What? Negatives. And give me examples of integers. Yep. Good. 2, negative 3, 5, 110. Do we understand what an integer is now? Okay, integer is like a whole number, but can be positive and negative. Got it? Yeah. Okay. You need to turn on your listening ears. Okay. All right, so this one includes an identity, right? So the nice thing about solving these graphically is we don't actually have to put the substitution of the identity in order for this to work graphically. We can graph it the way we see it. We're not going to use theta. What are we going to use? X. So we can literally put this in the way we see it and then solve just the way we have been doing it. So that's the perk of graphically, is you don't have to do that substitution to solve it out algebraically. So we're going to do 3 times sine of what? 2x, yeah, right in those parentheses, right? It's not a squared, so it goes in there. Minus cosine x. Okay? So you just put it in the way you see it. That's the benefit of doing this graphically with the identities. Now what? Yeah, window's ugly, right? What do you think my maximum is going to be? If I don't like it, I can change it. All right, we'll try 1. What do you think my x maximum needs to be? Yes, that's given, right? Okay. Y minimum? All right, negative 8, we'll try it. X minimum? 0, good. Do I like my y maximum? No, I want it bigger, right? What do you want to try? 8, okay. All right, so that's not too bad, right? I probably want to stretch it out a little bit more, make that a negative 4, make this 5. So that's going to give me a little bit of a better view. Okay? All right, so go ahead and find those solutions. Hold on. Okay, so your first solution is 9.6. Good. Second solution, 90. Third, fourth. Okay, so 9.6, 90. And 270. Great. What do you think? It's not bad, right? Just have to make sure you type it in right. Like Brittany said, this is a great way to check yourself. If it says to do it algebraically, you can make sure that you're correct by graphing it and finding those solutions. Okay? So that's a really nice, easy way to check and make sure that you're correct. Okay, I think there's one more. Go ahead and give it a shot. Okay, so how many of you got something that looked like that? Yeah, it's not pretty. That's okay. You're going to get functions that are not pretty. Okay, you have to get used to that. So that's what it looks like. So the zeros, again, pretty simple to find. Menu, geometry, points and lines, point on. We're going to grab that point, and we see a 0 at 210. It's a minimum. Maximum, and another 0 at 330. 210, 330. I don't, well, and 270. Okay, even though it says minimum, if you look at the actual point, it says 270, 0. So that's also a solution. So 210, 270, 330. Okay? All right, your homework for tonight is pages 14 and 15. Again, tomorrow we're going to go over any questions that you had from last night's homework, tonight's homework, and we're going to do some practice. Okay? Good.